Hello, my name is Prisho. Today, me and my group members will do a measurement instrumentation project, that is CL1. Okay, basically we will explain about the sensor in the lab. Today the sensor that I am going to explain is flow meter sensor. There are many types of flow meter sensors in the world, and each of the flow meter has a specific function. Today I will explain about the positive displacement flow meter sensor. This positive displacement flow meter sensor has a function to measure the volume and the fluid flow rate. Now I will explain how this positive displacement flow meter sensor works. Okay. You can see that this positive displacement flow meter sensor has rotating parts or turbine blade. This turbine blade is used to measure the volume and the flow rate of the fluid. Okay. As the water starts to flow, it will trap in the space between the turbine blade. As more water starts to flow, it will cause the turbine blade to rotate. Beside the turbine blade, there is a transmitter connected, and the transmitter got sensor that will generate a signal that is generated by the rotating blade. The transmitter then change the signal into electrical signal that will be displayed in computer or digital display. That is from me. The rest will continue by group member.
Hi, a very good day to everyone. My name is Ju Yong-sen. For my part, we will have to describe how the signal of the flow sensor is being analyzed. When the water flows through the flow sensor or the flow meter, the magnetic rotor will spin at a rate proportional to the flow. The magnetic field turning will generate a series of voltage pulses. And now I'm going to describe how we're gonna transform the voltage to the volume flow rate. So in our lab, we are using the DAQ system, which is the National Instruments. The flow sensor has to connect to the National Instrumentation NI9201. For this part, we have to use the software in the laptop to show you. We first open the NIMax. So this one, which I have prepared earlier. When we start the machine, we will see the running. So when this runs, we have to stop and save. So now we have to use the Daisy Lab. We have to use the Daisy. In Daisy Lab, we have the voltage pulses produced by the flow sensor. Now we need to use the analog input to input the voltage. We then change the voltage to frequency by using the pulse analysis. Here is the pulse analysis. We connect it. You can see that the pulse analysis will change into frequency. Then we press OK. Then we need to do a calibration to get the values of A and B into the scaling. Inside the scaling, we see that it needs the value of A and B. How we gonna get the values of A and B? First we have to measure the time for the tank to fill out 5 liters of water. The volume divided by the time will get the volume flow rate. We then need to plot a graph. We have volume flow rate. We need to plot a graph of frequency versus volume flow rate. Then we will have an equation y equals to ax plus b. That's our A and B. Then we can substitute inside the value of A and B. Then we press OK. Then after that, we will need another scaling to change our unit. For our case, unit conversion, we need to measure the volume flow rate. Therefore, we change it to liter per minute and OK. Finally, we connect it to the digital meter. The digital meter will display our volume flow rate. I think that's all from me. Thank you.
My name is Richard Wee, metric number MA11071. Now, I would like to proceed to describe the sensitivity of the sensor. Sensitivity of the sensor is defined as the slope of the output characteristic curve. Not generally, the minimum input of the physical parameter, there will be a decayable output change. This is the curve watched against the engineering unit. This slope is equal to sensitivity and operating within the linearity range. Okay, for example, for our positive displacement flow sensor may have a sensitivity rating of 10 mW per watt per volumetric flow rate. There will be a 10 mW output voltage, and for each watt excitation potential and for each volumetric flow rate it stands. But for the real world case, there will be a sensitivity error. There will be departure from the characteristic slope. Like the example below, our sensor may have an actual sensitivity of 7.8 mW per watt per volumetric instead of 10 mW per watt per volumetric. So that we can conclude that every sensor has its own sensitivity and operating in range. Thank you.
Hi, I'm Koso Singh, metric number MA11067. And for my part, I would like to describe the application of flow sensor in pipe friction experiment. So this is our pipe friction apparatus. So the first one, the flow sensor is here. Okay, our flow sensor is here. Then these two are strain gauges, and this is a national instrument. Okay, and then this button is to prevent the water flow out if we press it. Okay, and this is a power button. And here we got the adjuster of the flow rate of water. So in this experiment, we need to determine the head loss and measure friction factor, calculate friction factor, and the most important is to determine the pipe friction loss. So the strain gauges is used to determine the P1 and P2, which can obtain the head loss. Okay, so after we switch on the power, the flow sensor will generate the voltage into the frequency. Then by using the daisy lamp. So by this experiment, we can determine the head loss, pipe friction loss by using this experiment. Okay, that's all from my part. Thank you.
Assalamualaikum and a very good day everyone. My name is Ahmad Rizwan bin Hasanuddin. My metric number MA11077. Today I want to describe the application of the positive displacement flow sensor in industry. As we all know, positive displacement flow sensor is very accurate to measure fluid flow and can be used in viscous and corrosive fluid in certain pressure. This type of sensor is appealing in certain custody transfer flow application where it is critical that the sensoring be functional in order for any flow to take place. It is very widely used, especially in industry that have transfer of oil and fluid procedure. For example, in power and energy industries, the sensor used to detect deionized fluid flow in the machine. This deionized fluid is removed because it cannot generate energy for the product of the industry. Other than that, it used to monitor the pump in marine industry. Moreover, pharmaceutical industry use the sensor to demineralize water and detect any acid and caustic that danger to our health. And not to forget, it is also used to ultra clean monitoring in our food and process industry. That's all.